Anyway, one of the key mysteries about Mars is, all right, think of this, all right? You've got a planet which is farther away from the sun than we are, right?
Right.
So it's colder.
Colder, yes.
Okay. It's obvious that Mars had rivers, had lots of water.
Oh, yes.
Had floods.
Oh, yes.
Okay. Now you got a problem. Because in order to have floods and rivers and all that, Mars had to be warmer than it is now.
Correct.
How do you get a warmer Mars if Mars has always been exactly as far from the sun as it is now? Mm-hmm. Which, for the sake of argument, we can definitely assume, okay?
Well, let me take a stab at it. That won't necessarily meet up with your hyperdimensional physics, but the warmth of a planet is to some degree determined by the density of its atmosphere.
Very good.
And that a lot of atmosphere that used to be there is not there anymore.
Very good.
So that's one possible answer.
Okay. Now, what you need to do is you put numbers to that, and when you do the numbers, and I'm not talking about our numbers, I'm talking about numbers in the literature, it doesn't really work. Sagan invoked what he called greenhouse gases, the same concept of Al Gore.
Yes.
There are natural greenhouse gases. They're primarily ammonia and methane. And in some of his early papers, Carl, in attempting to solve this really interesting puzzle, proposed that in the early billions of years of the solar system, there was a lot of methane and ammonia that was, mixed in with the other gases of Mars' much more luxuriant atmosphere. And those gases would trap sunlight and then be like a blanket and keep the planet warmer and allow for liquid water and rain and oceans and all that. Okay?
Here, yes.
There's only one problem. Other guys said, but Carl, those gases are very easily destroyed by ultraviolet, and they did calculations showing that the greenhouse gases would dissipate, be ripped apart within years, and so there'd be no more blanket and no more greenhouse. So, and there's another problem. The standard models of the sun claimed that in the early years, billion, 2 billion, 3 billion years ago, when Mars was younger and was supposed to have these rivers,
right,
the sun itself was 30% dimmer than it is today. So you got a compounded problem. You have a planet far from the sun, farther than the Earth, which would be even colder if the sun was 30% dimmer than it is now. Now, the elegant, exquisite solution to all this is that the current model for what makes the sun shine is wrong. It's not primarily thermonuclear fusion, it's hyperdimensional physics. And in that model, the sun was brighter then than it is now. Ergo, without greenhouse gas trapping, you could have rivers on Mars and a warmer Earth, and the paleontological evidence from Earth indicates that we have been getting cooler, and it used to be much warmer a long time ago on this planet, which all neatly fits with the theory and is part of the testing of the model.
All right. Richard, a lot of people are going to be reading your paper on your website, and they're going to want to respond to it. Now, you don't have email. For some indiscernible reason, you don't have email. And
because I don't have dummy on my forehead.
You don't seem to want email.
No. The simple problem is simple logistics, all right? I do not have the time to go through 300 to 500 emails per day. So what I'm trying to do is set up a filtering system. If people really want to reach me, there's a fax number on our website.
Mm-hmm.
All right? I answer the telephone more often than I probably should. So what I'm trying to do is to screen people who really want to care enough to not electronically dash off something, but put it on a piece of paper and fax it.
All right. Let us give out at least your fax number.
Okay.
All right.
505.
505.
771.
771.
0820.
All right. That at least gives somebody one way of responding to you.
Yep.
Okay.
Now, they can send, email to, we're actually going to change this very shortly because it has gotten to where we want technical input and people do rely on email. But I have not been able to handle the logistical problem of thousands of emails per week. I mean, we're not keeping up with what we're trying to do now because we do not have paid staff. I mean, this is a very small research political effort to try to change a very big problem.
Mm-hmm.
And we do not have the bucks to do that.
Okay. Very good. Look, I would like to begin taking calls
Good idea.
If you wouldn't mind.
Absolutely.
You wouldn't mind?
More than wouldn't mind. Let's do it.
All right. Is there anything you want to sweep up before the top of the hour here?
How much time we got?
I don't know. About 4 minutes.
Okay. Tom, the essence of good science is predictions that turn out right. We have 2 of them on the boards tonight.
Well, the essence of good science is not necessarily predictions that turn out right. It's predictions. It's the scientific method applied to predictions to either prove or disprove them.
Well, but if your theory is wrong, you're only going to know it if
well, it's good. It's still good. It's still good science to prove a theory wrong.
All right, we're talking process versus results.
Yeah.
All right, I'm talking results. All right, you'd like to have your models prove out correct.
Sure.
I mean, no one likes to spend their time doing something that doesn't work.
Well, I was just pointing out that good science can also be proving something wrong.
Yes, we are not in disagreement. Okay, 2 points. Remember the Pod-Lenkoff experiment?
No.
Anti-gravity over spinning superconducting
Oh,
disks?
yes, of course, yes.
Of course, yes.
Thank you.
Well, hot new news tonight. I cannot tell you my source. It is not on NASA's official website yet, but according to an impeccable source that I talked to this afternoon, not only did NASA conduct the experiment 3 days ago, but they announced through a phone call to my source that it turned out to be positive. They are getting null gravity, less gravity over the spinning superconducting disk at the Huntsville Marshall Space Flight Center experiment.
Oh, my.
That is predicted by standard theory.
Oh, my.
And it's exactly in line with the hyperdimensional model.
All right, now, give everybody a brief explanation of the experiment. Would you please? Very brief.
Several months ago, there was a Finnish scientist named Pod-Lenkoff who announced that if he took a disk of superconducting material and spun it and put a test mass that was not electrically conductive above it, that the little mass would lose weight. 0.3%, I think, was the number that was quoted in his paper. All right?
Mm-hmm.
A lot of people were shooting at him. You know, there was a paper he was going to, put out new, and then he had to withdraw it. And there was a lot of, acrimonious finger pointing and stuff on the internet and back and forth. NASA's people at Huntsville, at the Marshall Space Flight Center, quietly announced they were going to set up the experiment and see if he was right. It has now been over a year, and in December and January, they reported null results. Now they're reporting quietly to my source positive results. Now, we tried to call one of the co-experimenters tonight, and it was too late back east to get confirmation directly for airtime. But the interesting thing, of course, is that normally when you run an experiment, you shouldn't get a null and then a positive, unless you've done something really wrong.
That's right.
That's part of the problem with the cold fusion people. When Pons and Fleischmann first announced their remarkable experiments, people couldn't duplicate them. Well, the hallmark of the hyperdimensional model is that things you do today, you can't do next Thursday. But you can do them next Saturday, because it varies with time. It's cyclic, based on literal astronomical phasing, where the moon is, where the planets are, how the planet rotates, all that stuff. It's geometric. And the modulation being geometric, it's not going to be reproducible every single time by anybody, anywhere, at any latitude, unless you take that into the equation.
But if in fact we have reduced gravity,
yep,
then that is the first little baby step toward eventually possibly even eliminating gravity or going to a negative state in which one could turn the beat around, so to speak, and you would have a vehicle that would operate using gravity, virtually anti-gravity, yes?
Yeah, anti-gravity, and what my thinking is, and what we're going to talk about at the Barwood dinner, is that what the public NASA guys, the honest part of the system, are now beginning to duplicate is what the black projects have been doing very successfully for probably the last 10 or 20 years.
I can buy into that one. I think I had one of those things fly over my head. All right, we're going to pause here at the top of the hour, and when we come back, in those markets in which we come back, which are many, we are going to take calls. So if you have a question for Richard Hoagland, now is a good time to pick up the phone and begin to dial. You know the numbers. I'm Art Bell, and this is Coast to Coast AM.